In this video, we're going to talk about those trig rules that we talked about in the last video, but we're going to also nest them inside some other rules. So for instance, here we have, in this first example, what I have is a power rule problem, and it's nested within it is one of those trig rules that I have to deal with. So let me show you another way to write this so that you can follow it a little bit better. So here, if you think of this as the sign of the argument x cubed, and then that quantity is raised to the fourth power, well, we see this as a power rule problem first. So what we have to do first is apply the power rule. So we bring down the power, and so we get the 4 from the power. And then we would have this same function written to the third power. Now I went ahead and written it the way it's normally written, but this would be 4 times the sine of x cubed, and that quantity would be raised to the third power. So that's that 3 right there comes from the power rule. But then you have to multiply by what's inside. And what's inside here is the sine of x cubed. And when I say multiply, I meant to say the derivative of what's inside there. So you have to multiply by the derivative of sine of x cubed. So I went ahead and wrote that here because this might be a little bit difficult to do in your head. So now let's think about, from the last video, how we learned how to take the derivative of sine u, where u is some function of x. So remember, to take the derivative of this, we would actually get cosine of u, and then we would multiply by the derivative of u, which is x cubed. So we'd have cosine of x cubed times the derivative here, right here, of x cubed. And then we know in the next step we can go ahead and take the derivative of x cubed, and we get 3x squared. Now I just went ahead and brought these other terms down. So we had 4 sine cubed of x cubed, right? We brought it down. And then from up here we had cosine of x cubed, so we brought it down. And then when we took the derivative of x cubed, we got 3x squared. Now all I did to finish it was I have a 4 here, and I have times 3x squared here. So 4 times 3x squared is 12x squared. So I get 12x squared times the sine of x cubed cubed times the cosine of x cubed. And that's your derivative of that function. Now over here, I have the square root of the cotangent of 5x. Well, that's the same as saying we have the cotangent of 5x raised to the 1/2 power. So I can apply the power rule to this and get 1/2 of the cotangent of 5x raised to the negative 1/2 power. But then I have to multiply by the derivative of cotangent of 5x, because remember what's inside? The cotangent of 5x. So when you do the power rule, you have to multiply by the derivative of what's inside. So we multiply by the derivative of cotangent of 5x. Now think back to the rules from the previous video. The derivative of cotangent of u is minus cosecant squared of u. So it would be minus cosecant squared of 5x. But then remember, we have to multiply by the derivative of that argument. So we multiply by the derivative of 5x. Now all I did was just brought this part down to this step, and then I brought it down to the next step. And then I brought this minus cosecant squared of 5x, I brought it down. And then I went ahead and took the derivative of 5x, and that's where I got the 5. Now let's talk about what's in the numerator and what's in the denominator here. Well, we know the 2 is going to be in the denominator, and we know we can move this to the denominator and change it to the positive 1/2 power. But remember, cotangent of 5x to the 1/2 power is the same as the square root of cotangent of 5x. Now what's in the numerator? Well, in the numerator I have minus this cosecant squared of 5x times 5. So I'm just going to put the 5 first, and I'll get minus 5 times the cosecant squared of 5x. And so now I have my derivative minus 5 cosecant squared of 5x over 2 times the square root of cotangent 5x, and that is your derivative. Okay, now on the next two, I'm going to make you think a little bit because I didn't write I'm fixing to take the derivative steps that I wrote on some of the others. But on this, I'm going to use the product rule. So really what I have here is I have a product because I have x cubed times the sine of x squared minus 2x. So let's think back to the product rule. What do you do for the product rule? Well, you can write the first function, which is x cubed, and then you multiply it by the derivative of the second function. Now, to get the derivative of sine u, remember this is sine u, where u is x squared minus 2x. So how do I get the derivative of sine u? Go back and look at it, and you find that the derivative of sine u is written as cosine of u. So I would have cosine of all of that, and then multiply it by the derivative of u. So now I have to multiply it by the derivative of x squared minus 2x, which is 2x minus 2. So that's where the 2x minus 2 came from. That's the derivative of this argument, x squared minus 2x. And then I take the second function, which is just sine of x squared minus 2x, and I multiply it by the derivative of the first function. So the derivative of x cubed is simply 3x squared. And then the rest of this is just kind of rearranging things a little bit. So for the first term, I just wrote the x cubed, then I put the 2x minus 2 here, so I get x cubed times 2x minus 2 times the cosine function. And then here I just copied the second term down, 3x squared times the sine of that function x squared minus 2x. And so that's your trig rule applied to, well, that's a product rule that also involves trig rules. Okay. Now let's look at a quotient rule that also involves trig rules. So here I have the tangent of 2x cubed minus x all over x squared minus 1. So if you'll remember from the quotient rule, if you take the derivative of u over v, the way it works is you write v, so that would be the bottom, x squared minus 1, and then you multiply it by the derivative of u, the numerator. So now if I take the derivative of tan u, remember the derivative of tan u, where u is this polynomial, would be secant squared u. And then remember I have to multiply by the derivative of this polynomial, the derivative of this argument here, u. And the derivative of that would be 6x squared minus 1. So ultimately the derivative of tan of 2x cubed minus x is secant squared of 2x cubed minus x times the derivative of that 2x cubed minus x, which is 6x squared minus 1. And then in the second half of the quotient rule in the numerator, I would have the function that's on top, the u. So I would have tangent of 2x cubed minus x, and then times the derivative of what's in the denominator here. So the derivative of x squared minus 1 is simply 2x. And then don't forget on the bottom here, you take the denominator and square it. Now the last step, again, I was just kind of rearranging the order of these. So I went ahead and put the x squared minus 1 and the 6x squared minus 1, out here in front of the secant squared factor. And then on the second term, I went ahead and moved the 2x in front of the tangent factor, which, may not be a big deal to your professor, but I usually like to put polynomials to the left of trig functions so that you don't get caught up thinking that this 2x is part of this argument. So anyway, that kind of clears that up. Now again, these examples that I just did here, you don't really need to worry about these if you're in a business calculus class, because most business calculus classes do not cover trig functions. But if you're in a Cal 1 class, these are very helpful. Now in the next video, I'm actually going to go ahead and cover the derivatives involving exponential and log functions. In a lot of courses, they wait till toward the end of the course to give you those formulas, but I'm going to go ahead and just bring them in now so that way we can get all of our derivative rules covered in this section on calculus conundrums finding derivatives. So we'll see exponential and log functions in the next video.